So now come to the sign convention in the case of the mirror. Sign convention in case of curved mirror. Suppose we plot the concave mirror. So this is your principal axis, this is the pole, this is the center point of the mirror, this is your center of curvature, and this is the focus. So for the sign convention, first we will consider the pole, the position of the pole that will be considered as the origin. So we will just consider it as the origin. So this will be your 0, 0. So now this will be your x-axis and this will be your y-axis. So the incident ray, suppose the incident ray coming from the left of this direction. So all the distance which are measured opposite to the direction of the incident ray, it is taken as the positive. This is the first rule. So rule number 1 or number 1, just we can write that all the distances are measured from pole. So this is the first rule of the sign convention. Second rule, the distance measured along the direction of incident ray is taken as positive. It means, suppose if we are measure the distance along this direction, so this will be taken as the positive, and the distance measured opposite to the direction of the incident ray, suppose we are measure this distance that is opposite to the direction of the incident ray, so this distance that will be taken as the negative. So we can write the third point, that the distance measured opposite to the direction of incident ray the distance measured along the direction of the distance measured opposite to the direction of incident ray is taken as negative. Now rule number 4. So all the distance which are measured, so this is your principal axis. So all the distance which are measured above the principal axis, suppose this distance, so the distance measured above the principal axis, this is taken as the positive, and the distance measured below the principal axis is taken as the negative. So we can write rule number 4, that the distance measured above the principal axis is taken as positive, and the distance measured below the principal axis is taken as negative. So this is about the sign convention in the case of the mirror. So this sign convention is applicable for the concave mirror as well as the convex mirror both. Now in the short form, we can say that suppose this is your mirror, this is your principal axis, so we consider this pole as the origin. So first thing, that this pole we consider as the origin. So the distance measured along this direction, means along the left direction, that is taken as the negative, and the distance measured right of the pole is taken as the positive. The distance measured above the principal axis, that is taken as the positive, and the distance measured below the principal axis is taken as the negative. So this is your brief about the sign convention in the case of the all type of the mirror, for the concave mirror or the convex mirror. So let's come to the problem. So first we draw a diagram for the image formation. So this is center of curvature and this is the focus. Suppose object is placed here, and suppose in this case the image formation takes place at this position. So I have taken a random condition or random case. This is your object and this is your image. So the distance measured from the object to the pole, that is called the u, and this is your object distance. And the distance measured from the image to the pole, that is called the image distance, and it is represented by v. We can say that what is u? U is the object distance from pole. and V is the image distance from pole. All the distances are measured from the pole, and this is called the distance measured from the focus to the pole, that is called the focal length. It is represented by F. So F here, that is it is a focal length. If we say that in the case of the concave mirror, this focal length that is left of the pole, so we can say that here the focal length will be negative in the case of the concave mirror. F will be always positive. Sorry, it will be always negative, because this focus that lies left of the pole, so it will be always negative. And U also lie at the left of the pole, so it will be always negative. And the V, it depends on the sign of F and U, all as well as the location of the object. Now we will come to the what is the mirror formula. So mirror first formula, that is your 1 by V plus 1 by U is equal to 1 by F. Second, the magnification. So magnification means what? So magnification, it gives idea about what is the size of the image and what is the direction of the image. So magnification, that is equal to magnification, it is represented by a small m. So this is equal to, it is the height of image divided by the height of object. And this is equal to, we can write height of image, that is represented by hi, and the height of object is represented by ho, and this is equal to minus V upon U. So only these two equations are used to solve the problem in the case of the mirror. In the same way, so now we will solve one problem. Suppose this is your mirror. This center curvature and this is focus. Suppose in this case the focal length is given as, suppose 20 centimeter. And suppose object is placed at this position. Suppose this position is your 30 centimeter. Suppose the size of object is, this is your HO, that is equal to 2 centimeter. So in this problem, I have to determine what is the size and the location of the image. Determine size and location of image. Now from the sign convention we can write that. So in this case the focal length will be negative. So first we will write the input data, that is focal length, that is given as it is minus 20 centimeter. And the object distance, that is equal to u. So u will be also, it will be negative, that is equal to minus 30 centimeter. So from the mirror formula we can write 1 by v plus 1 by u is equal to 1 by f. Now just put all the values. So we can write 1 by v plus 1 divided by minus of 30 is equal to 1 divided by minus of 20. So we can write 1 by v is equal to, it is 1 by 30 minus 1 by 20. So this is equal to 60, it is 20 minus 30. So this will be 60, it is 2 minus 3. So we get v is equal to minus 60 centimeter. Minus 60 indicates that the image formation takes place in the same side as the side of the object. So suppose it forms here something here. This is your image. So we have find the location of the image. Now what is the size of the image? So first of all, we have already got v is equal to minus 60. So we can determine what is the magnification. So magnification m is equal to minus v by u, and that is equal to minus of v is given as minus 60 and u is given as minus 30. So we are getting as minus 2. This minus sign indicates that the image will be inverted. I write here that negative sign indicates that image will be inverted. So we can write m is equal to height of image divided by the height of object, and this magnification is equal to minus 2. Height of image and height of object is given as 2 centimeter. It means the height of image, that will be minus 4 centimeter. Minus indicates that the image formation that will take place below the principal axis. Image will be formed below the principal axis. So this is the problem that is based upon the concave mirror. So we will take one more problem that is based upon the convex mirror. Suppose this is your convex mirror. Suppose the focal length is given as 20 centimeter. Suppose this is your C and this is your F. Now object is placed, suppose their object is placed we are taking size as the 2 centimeter, or we can take as the 4 centimeter. Suppose the object distance from the pole, this is your pole. Suppose we take this distance as the 40 centimeter. So determine the location and the size of the image. Determine location, size and nature of image. So in this case, the object is in the left of the pole. So the object distance that will be taken as the negative. This distance is, it is opposite to the direction of the pole, in the left direction of the pole. So we will take here input u is equal to as the minus 40 centimeter. In this case, this is the focal length, this is the focal length. So focal length, it is a right of the pole, so it will be taken as the positive. So we will write f is equal to, it is your plus 20 centimeter. Again we will use the mirror formula. As we know that 1 by v plus 1 by u is equal to 1 by f. Now substitute the value here. So here 1 by v plus, here u is minus 40 plus, that is equal to 1 by plus 20. So 1 by v is equal to 1 by 40 plus 1 by 20, and this is equal to 40. This is 1 plus is 2. So v is equal to, we are getting 40 by 3 centimeter. It means the location will be between P and F, something here. Image will be formed between P and F. Now come to the magnification. So m is equal to minus v by u, and that is equal to minus of v is your 40 by 3 and u is equal to minus 40, and that is equal to 40 by 3 into 40, this is equal to 1 by 3. So m is equal to 1 by 3, it represents that the image will be diminished, image will be smaller as compared to the size of the object. So we can write 1 by 3 is equal to, it is your height of image divided by the height of object. So we can write 1 by 3 is equal to height of image, and the height of object is given as it is 4. So the height of image, that is equal to 4 by 3, and this plus sign indicates that the image will be formed above the principal axis. Okay, thank you.